All right, and now for problem 7 from our fall AMC 10A from 2021. It's also the 12A problem 6. As shown in the figure below, down here, point E lies in the opposite half plane determined by line CD from point A so that angle CDE is 110. Now you might be like, what's this opposite half plane? You know what? It doesn't matter because they gave us a picture. So you don't have to think about that too much. I mean, maybe a little bit, but I wouldn't waste a lot of time, trying to calculate, wait a minute, what do they mean by, is that some kind of a trick? Because they're tricky sometimes. But luckily, the picture's kind of giving it all away. Then since it says picture not drawn to scale, then you should probably worry about proper interpretation there. Point F lies on AD, and you see it right here, so that DE is equal to DF. Mark it right now. That means this is an isosceles triangle. And ABCD is a square. What is the degree measure of angle AFE? That's this angle out here. Well, you might be like, well, this is an exterior angle to the triangle, and so these must add up to 70. And then you're going to get it wrong because that's not an exterior angle of the triangle. The exterior angle would be this one. And so if you wanted to, I guess one thing you could do, since the whole thing is 110 and this much is 90, this would be 20. And then you could use your exterior angle knowledge to come up with this is 10 and 10. I'll put it like this so you can see it. Those two angles are 10. In an isosceles triangle, the angles opposite the equal sides are equal. That should be very common knowledge for most of you. And if you're not acquainted with these kinds of tests, this goes in the small notebook. It comes up all the time. So the other way you could have done it, you could have taken the whole 110, added this 90 to get 200, and then you would know that the whole angle here is 360, and so it would leave in that triangle, basically, you would have a 160 degree angle. And then again, since you knew these two angles were equal, they would both be 10. Now, how does that help us? We want AFE. AFE, this outside angle, you could do it two ways again. You could take this 160 plus the 10, or you could just take this 10 and subtract it from 180, because the angles on here make up 180. So you're going to get 170, answer choice D. I hope you're making good time at this point in the test. Let's get to the next problem. And so here we are, continuing with the fall 2021 AMC 10A problem 10. The last problem of this rapid fire set. It's also the 12A problem 7. A school has 100 students and 5 teachers. Okay, in the first class period, each student taking one class, each teacher teaching one class, logically. The enrollments in taking the classes are this. Let T be the average value obtained if a teacher is picked at random, and the number of students in their class is noted. Okay, so there's only 5 teachers and these are the number of students in their classes. The averages formula that I prefer is a sum with a subscript of n divided by n is the average of those n things. In this case, the n is a 5 because there's 5 teachers, 5 entries in our calculation. So then, if we add them up, we know we get 100. It told us earlier. So you're going to get 100 divided by the 5 teachers is a average of 20. That must be T. Not so bad. The next one's a little trickier, but not too bad. Next up, let S, and I put these little marks because I can't write in italics, be the average value obtained if a student is picked at random and the number of students in their class, including that student. In other words, if you're in this class, you don't put 49, okay? Including that student is noted. What is T minus S? So in order to do the student one, there would be 50 students who all would give a value of 50. So I actually thought of 2 ways to do this. The first way I thought of was expected value, and that should work, but I didn't have perfect confidence that it would, and I knew this method would work. So first I did this. So I did 50 times 50. That's 50 entries of 50. There's going to be 40 entries of 20, and there's going to be 10 entries of 5. And then I'm going to divide that by 100, but I'm going to write that as 10 times 10. Why 100? Because there's 100 entries. Each student is an entry into the average. So this 10 will cancel that 10, one of these zeros and one of these zeros. So we get 250 plus 40 times 2 is 80 plus 5 over 10. And so you get 335 over 10, which is a decimal place in, and you're going to get that S is 33.5. Now, I did later on, after I was done timing myself, going through the test, I went back to check to see, I felt like it should work, but I just didn't have perfect confidence. You know how you doubt yourself, which is a good habit to kind of be in as long as it's not excessive. And I went back to check the expected value. How does expected value work? It's the probability that a student from this group is chosen, which is 1 out of 2, because 50 out of the 100 students. So you're going to get 1 out of 2 times the value for that chance, which is 50. And then you're going to add, there's 40 students, which is 40 out of 100. That simplifies to 2/5. The probability of selecting one of those students is 2/5 times their value of 20. Each of them are going to say 20. Even though they're in different classes, they'll still say 20. And then you're going to have 10 out of 100, which is 1/10. I don't have space. Plus 1/10 times their value of 5. If you calculate this, you're going to get 25 plus 40 over 5 is 8, plus 5 over 10 is 0.5. You'll notice it's 33.5. If you had the confidence to do it that way, awesome job. And then if you didn't even, you could do it both ways and feel very confident that the answer will be T, which is 20 minus 33.5. You're going to get B, negative 13.5. Sometimes doing a problem 2 different ways, as long as they're quick, can have a great effect, because then you're not worried about that problem as you move forward. And 11 was quite the challenge. Let's get to that for problem for AMC 10, and we'll be right back. Okay, so we are now filming today for the AMC 12. Didn't have time to film yesterday. Sorry for you AMC 12 test takers. I just only so many hours in the day. We get done what we can. This is the fall 2021 AMC 12A problem 8. Let M be the least common multiple of all the integers 10 through 30 inclusive. Let N be the least common multiple of M, all of that as well, and all of that. What is the value of N over M? This one I tried to do in my head, mostly because when I was trying to solve it, I was kind of tired and I was like looking at my phone trying to figure it out. It's better to use paper. Yeah. So I eventually got a piece of paper and was just like, let's just be sure how this works, and that made it a lot easier when you're using paper, I guess. So here we go. The least common multiple, I have a little saying. For the least, you want the greatest, and for the greatest, you want the least. What does it mean? When you're doing greatest common factor, you want the lowest powers possible. When you're doing least common multiple, you want the greatest powers possible of the primes. It has to be prime factored first. So if I want M to be the least common multiple of all of these integers, 10 through 30, and I want that to be in the denominator, M is going to be the highest power of all the primes in all of those numbers individually though. So for example, 2 to the 4th is 16, 2 to the 5th is 32. We don't have 32, so we're just going to put 2 to the 4th. You obviously don't want to make a list of all those numbers, but if you understand that for the least, you want the greatest, it isn't that bad. What's the highest power of 3 you have? 27, which is 3 to the 3rd. What's the highest power of 5 you have? 25, which is 5 squared. Everything else doesn't have any squares, so you're going to have a 7, an 11, a 13, a 17, a 19, a 23, and a 29. Now that's what M is, and it's down here. N is the least common multiple of this expression and all these numbers. Well, does that mean that all of these just appear up here and you get some giant number? Not exactly. I need the highest power available, but now I've got access to 32, so I'm going to have a 2 to the 5th. As for 3, the highest power of 3 available is still going to be 3 to the 3rd, because it comes from M, and I include that, and this is M, so I have access to 3 to the 3rd. For 5, there is no 5 to the 3rd. You're going to have a 5 squared. We don't have access to 49, so I'm going to get all of these. I'm just going to put ... 29. Is that it? No. And now we kind of might have wondered, why did this one go through 30 and this one not have 31? I'm almost wondering what's 74 times 31? This is going to be the answer, by the way. 70 times 30, right around 2100. I don't think it's that. It's not that. 4 and 1 doesn't end in 6. I just thought maybe they would get somebody with that one. But basically this, what do we have left? 37 is a prime number in this range. And so it has to be tacked on to n, but it's not part of m because m doesn't have access to 37. So then what's going to happen? These 4 powers cancel 4 of these powers and leave you with 2. Everything else cancels all the way through. All of these primes are part of this one, all of them. And so 37 will then be the only prime in this range. 31 was prime also. That's why I thought maybe that's why they didn't include it. But 37 is the only other prime in the range of 30s. So 2 times 37, you're going to get 74. Let's get to problem 9. All right, this problem, if you were in my class or one of the classes with me where we reviewed past tests, there were several components in those past tests that I did this problem in less than 60 seconds. Like I just carved through it like butter. So I hope that those of you who had my class were able to recognize these things and capitalize on them in a quick fashion. A right rectangular prism whose surface area and volume are numerically equal. Immediately, if you want to draw it, you can, but your dimensions are like A, B, and C, length, width, height, right? So then the surface area is every product of one of these doubled because there's 2 equal surfaces on each side. So I immediately wrote 2AB plus AC plus BC equals, volume being equal is simply ABC. Now, I've seen something before in an older test where you simply divide by this and create 1 over. So I had that in my back pocket as a plan about what I might do going forward depending on what the rest of the problem has to say. So I left it alone for now, but that is in the back of my mind as I go forward in the problem. The next thing you read is it has edge lengths. So these are your A, B, and C, and they're logs, and there's something peculiar about them. The x, the thing that's the same in all of them, is this part. And there's something we learned in the class, and it would have been, it's a shortcut. It's just going to be that log base B of A is equal to 1 over log base A of B. In other words, you can, if you flip these, it ends up here. I'm not going to demonstrate that for you right now about why it's true. It's actually not that hard. You just use change of base formula. So for instance, I could call this log base C of A over log base C of B, and this would equal 1 over log base C of B over log base C of A. You can invert that. Those are the same now, okay? So this is a key fact that you have to know. It's just a big shortcut, not taught in your school math, typically speaking. I've never seen it in a textbook, but it could be in some parts of the country, but not locally, it's not. Now, why this matters is my earlier thought now connects. I just simply divide. I'm going to get 1 over fractions for all of them. So you're going to get 2 times, but I don't want that 2. I know what I want here. I've got 1 over A plus 1 over B plus 1 over C is equal to 1/2. And these are the reciprocals of these, which means the x and the 2 and the x and the 3 and the x and the 4 can swap positions, right? Because this will become log base x of 2 plus log base x of 3 plus log base x of 4 equals 1/2. And whenever you have the same base with logs, now we're just on the normal log rules, you can multiply their insides. 2 times 3 times 4 is log base x of 24 is 1/2. X to the 1/2 is 24. I want to square both sides. So you get x to the 1/2 equals 24. That's just what I call smiley frog face. And then you're going to square it to get to the x. 24 squared, 576. No problem at all. This is why you want to have these little memories, these little triggers that you just act upon. It's instinct, it's green light, go. You want to write them all in one location. And they're better if you've developed them yourself, not just copied them off of a list somewhere, but you've asserted to yourself that they're true. You've demonstrated it in some way. I call those small notebook concepts. If you'd like to learn more about that, watch the small notebook video, Justified and Explained. Let's get on to problem 10. Okay, for this problem, the fall 2021 AMC 10A problem 12, 12A problem 10, the last one of this rapid fire set, For this problem, you might want to pause the video and go watch a primer on modular arithmetic. There's one on my channel. It's got all caps modular arithmetic intro in the title. It might help you understand better what's going on here. The base 9 representation, wait, do I want modular? Yeah, we do. Base 9 representation of the number n is this ugly looking thing. Don't try to read it. No, that's painful. Just that's it. It's that number. It's all you want to do when you're reading. You're trying to go quick. You're not going to gain any benefit by looking at all this right now, okay? Just notice the 9 and that's about it. What is the remainder when n is divided by 5? Okay, so first, what is this in terms of why is it in base 9? It's so that you can write it like so. 2 times, and it's going to be 9 to the power of, this is 9 to the power of 0 place, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 9 to the power of 10, okay? Plus 7 times 9 to the power of 9, and I'm going to put a line underneath that as well, plus this is 9th power, 8th power, 7th power, 6th power, 6 times 9 to the 6th, plus nothing matters here. This is going to be 9 to the 1st power and 9 to the 0. So you will have 5 times 9 to the 1st plus 2 times 9 to the 0. A great book to get better at this is the Intro to Number Theory book from Art of Problem Solving. And so that's actually where I learned everything about number theory. I haven't learned it from any other source. So let's change this to a time symbol to be consistent. My OCD is going to get upset. So what do we do with this? How are we going to use modular arithmetic to figure out what the remainder is when we divide this by 5? Well, if you don't know what just happened, it's the same thing that happens if you do 471 in base 10. You would write 4 times 100, if you expanded it, plus 7 times 10 plus 1, which is 4 times 10 squared, even though it's in the 3rd position, plus 7 times 10 to the 1st, even though it's in the 2nd position, the power is only 1 on the 10, and then 1 times 10 to the 0. It's just that, you're just swapping out the 10s for a different base of 9, and that's what we did. So now, you might not know this, but if you do 9 is congruent to what in base 5? This is the congruent symbol for modular arithmetic. It would be congruent to 4, and you write mod 5. Not base 5, but mod 5. Sorry, it's the kind of same thing. So 9 is congruent to 4 mod 5, but did you know with mod, you can, with modular arithmetic, modulo 5, those are the proper words, I'm just shortening them, you can go into the negatives. You can actually say this is congruent to -1 mod 5 as well. And the reason for that is this is 5 times 1 plus 4. This is 5 times 0 plus 4. And this is 5 times -1 plus 4. It's the negative first multiple of 5 plus 4. Okay? So then that gives you -1. All of these numbers have the same quote-unquote remainder when you divide them by 5. So why does it matter? Because if I have 9 is congruent to -1 mod 5, if I take this to any power, I do the same to the other side, and it will still be a true statement. Which means this 9 to the 10th, again, I'm not going to be able to explain this in detail in this video. You can watch the other video to get more in-depth explanation of these ideas. It's like 3 chapters of a book. I can't summarize all 3 chapters in a short video. I did the best I could on the other one, the modular arithmetic intro one. Maybe I'll link it in the description if I have time at some point. But if I take 9 to the 10th power, then -1 will go to the 10th power. And this, we call it modding out. We can mod it out to be 1. And I will have 2 times 1, which is what this expression will become, plus 7 times, it'll be -1 because you have an odd power. So you're going to get -7, and then plus +6, because that's just going to mod out to 1. This is going to mod out to -1. This is going to mod out to 2. It's already modded out, basically, because the 9 to the 0 doesn't really matter. So what do we have now? We've got 2 plus 6 is 8 plus 2 is 10. And I do 10, and then I subtract the 7 and the 5, which is 12. I get -2. Now, just like I can start at the -1 and add 5 to get back to a positive number, So I can do the same with -2. If I take -2 and add the modulo back to it, I will get the answer they are looking for. It's going to be answer choice D, which is 3. And again, this is 5 times -1, the negative first multiple of 5, plus the remainder of 3. Okay, so that's it for now. Again, I'm sorry if it wasn't fully as clear as I usually do, but I've got to film a lot today. Watch the other one for a primer on it. It'll make more sense for those of you who didn't understand what I did. For the rest of us, we're going to move on to the next set for the 12 and problem 13 for the 10A. Let's get going.